I'm Eylül Karaman. I'm from Physics 101 course, section 6. I'm going to explain my experiment, projectile motion of the cylinder. This experiment aims to understand the relationship between the range, the horizontal velocity, and the acceleration of the projectile motion. While understanding the relationship, the aim is to find the acceleration as well. Before getting into the experiment, let me explain the theory behind it. My calculations mostly came from the very basic equation of the physics. It is distance equals to velocity times time. The distance in my experiment will be the range, velocity will be the horizontal velocity of the projectile motion, and the time will be the flight time. But I need some other formulas, and I need a formula that will give me the acceleration in terms of what I know. So I made some calculations before starting to experiment, and I achieved this last formula. Equipment for this experiment were two inclined planes at different angles, a cylinder as the object, a meter and some rulers to determine the distances and measuring the height of the inclined planes, and lastly a timer for measuring the flight time. After setting up the inclined planes, I needed to determine the angles of them because I couldn't do that myself with the equipment I had. So I measured the distances and the heights, and I did some mathematical calculations to determine the angle. The first inclined plane was at 26 degrees and the second was at 7 degrees. After determining the angles, I dropped my cylinder from the top of the inclined plane and it fell down. At the end of the inclined plane, the table ends as well, so from that the cylinder makes its projectile motion and falls to the ground. I dropped the cylinder a few times before actually doing the calculations and the experiment to make the motion perfectly and smoothly. After deciding that it's gonna be okay, I started my experiment and did this procedure for the two inclined planes, and I measured my information. After getting these data, I filled out a table with vertical height, the angle, the range, and the time of flight, and lastly the horizontal velocity. Using the range and time information that I have, I calculated the horizontal velocity myself. After filling out the form and seeing all this information, I plotted a graph between range and the horizontal velocity because the slope of this graph will give me the acceleration of the motion which I need. After getting the slope, I first get a theoretical result so that I can compare it with my experiments result. Theoretical results were 0.92 for the 26-degree inclined plane and 0.85 for the 7-degree inclined plane. After this theoretical results, I went ahead and used my experiments information to get right experimental results. And the experimental results for the 26-degree plane, it was 0.18, and for 7-degree plane it was 0.05. As you see, there were some differences, and I think this is because of some errors. These errors can be the calibration of the measurement devices, which means systematical errors, but at the same time the cause can be me because I measured all of the things myself, and I can be a little late at stopping the timer. Maybe I missee the range of the cylinder. With this experiment, I learned how to create connections between different physical quantities. For example, in my experiment, I created a connection between range, horizontal velocity, and acceleration. The other thing I learned is that how to integrate different equations to each other to find what I need, like I did in this experiment to find acceleration. Thank you for listening.